Hello everyone. In this video I'm going to explain you Mercury VST fuel supply module. So one of my previous video I explained how Yamaha outboard 4-stroke VST is working, fuel supply module is working, and this video I'm going to give you all details that how this one is working, what is the purpose of this each part, and I hope this video will cover 90% of things that you should know about the Mercury VST. So VST, FSM, VST means vapor separator tank, and FSM means fuel supply module. So normally people call fuel pump. This is Mercury 300 VST, and 350 also almost same. First of all, I will open this one. Then I will show you inside everything, and I will explain you what is the purpose of this each part. I already removed this screw. I'm going to take this out. Then I'm going to explain you one by one each parts. Okay, first talk about this one. This is the fuel tank for the fuel supply module. This is the holding all the fuel. Supply the fuel from your boat fuel tank, and also distribute supply the fuel from the fuel pump to the fuel rail. Okay, you can see this copper tubing here. This is fuel cooler. In order to reduce the temperature of the fuel, they use this tube type cooler for cool the fuel. Most of VST working with the work with seawater cooling system. Okay. Okay, this is the complicated part that you should understand properly. I hope this video will helpful for you to understand the each separate parts, what is the purpose of this each parts. First of all, I will start from the lift pump. Lift pump means lift the fuel, take the fuel from your boat main fuel tank. You can see here, this is the fuel lift pump. What it does, it sucks the fuel from your boat fuel tank through the fuel filter or water separator, whatever filter you have. It sucks the fuel through those filters from fuel tank to the VST. From here, intake, so it's connected this pipe here, this connector here. So this is the fuel intake from boat fuel tank to the VST. And if you see this motor, this pump here, there's a filter, strainer. So this is strainer. What it does, it will of course it will filter the dirty. Still, even they have filter, still they could come some small amount of debris, so it will strain, it will filter by this strainer. This is the electrical supply to the fuel lift pump. Suck the fuel from here, then supply to the VST from here, inside intake and out. Okay, the next one is high pressure pump. So this is the high pressure pump, which means this is the motor, this is the pump that supply fuel from the VST to the fuel rail. So fuel rail connected to the injector is connected to the fuel rail. So this is the high pressure pump, this is the lift pump. And if you see high pressure pump, underneath the high pressure pump, there's one more strainer again, filter again, like a mesh. That's also again, even they have some debris, they can filter by this small filter mesh. Okay, this supply the fuel from the VST to the fuel rail. I will explain you also the how this one is working. First I will explain you each parts. What is the purpose of this each part? Okay, this is the electrical connection to the high pressure pump. This is for the low pressure pump, and you can see here this one. This is the float switch. What float switch does? Once the fuel is reached to the maximum level in the VST, so in order to stop the fuel supply, the lift pump should be cut off. So this floater switch gives the signal to the ECM. Once the fuel is full, it will give the message to the ECM, stop the lift pump, because fuel level already full. So this one, you can see this electrical connector, this electrical connection is bring the signal from the floater switch. If you move this one up, like upside down, you can hear that sound. That is the floater. Once the floater moves here, it will cut off the fuel lift pump. Okay, now you can see the high pressure pump is connected this connector here, which means this is the high pressure supply to the fuel rail. And I will turn other side. Okay, now you can see this one. So the next thing is this fuel pressure regulator. So I'm going to explain you what is this one and how this one is working. So fuel pressure regulator is what it does. It's control the pressure inside fuel rail, which means between high pressure pump and fuel rail. So it can regulate the pressure. It can control the pressure inside the fuel rail. So you can see this hose here. So this hose is all the way connected this connector. Then the hose is, if you trace this hose, it's connected behind the air cooler, so an intake manifold, so with very tiny hole. So this one doesn't have any electrical connection. It's regulate the pressure, depend on the pressure inside the air intake manifold. So if you compare the fuel pressure when you run idle and when you run high speed, you can see the fuel pressure is different, which means when you run the engine with high RPM, the fuel pressure is normally high than normal idle RPM. This one is like a relief valve. So depend on that pressure, it's work like a bypass valve. What happens that if the high pressure pump, if the fuel pressure is increased than desired level, so this valve will be open, then it will bypass, it will return to the VST, vapor separator tank. So the fuel pressure regulator doesn't have any electrical connection, but if you check the fuel rail, you will see the fuel pressure sensor. So if ever your fuel pressure regulator having issue, which means if your fuel pressure regulator is bad, so the fuel pressure of the inside the fuel rail will be different. So it will give you warning, because that sensor is give the signal to the ECM, then ECM will show you the ECM is give you warning on your Mercury display. So your fuel pressure having issue, maybe fuel system critical, maybe fuel pressure low, maybe fuel pressure high. So if your fuel pressure, if this motor, if this pump for this pressure regulator, any of these damage, that if fuel pressure is not in the range, so it will give you warning. So how that one is detecting with that fuel pressure sensor in the fuel rail. And also you can, if you trace this line, this hose is connected to the all the way to the air intake manifold, which means behind the air cooler. That is very tiny hole. If that tiny hole is clogged, which means sometimes I have experienced that small hole become clogged with like a salty or rusty. What happen? It doesn't calibrate the pressure, air pressure inside the air intake manifold. So the fuel pressure regulator is work as a idle speed, which means even you run high speed, even you increase the RPM, so it cannot calibrate the air pressure because this hose is already blocked. Like that situation, fuel pressure is stay like idle RPM, which means fuel pressure is less. So your Mercury display will give you warning that your fuel pressure having an issue. So if you having that kind of issue, that was my experience, that this hose is connected to the air intake manifold, that with very tiny hole. That tiny hole is clogged, so it's doesn't give exact fuel pressure. It will give you warning. So it doesn't have any problem with pump, doesn't have any problem with this fuel pressure regulator. Just trace this line and where they connected to the air intake manifold. If that one is clogged, so it will give you some problem, that you might thinking that problem is in the fuel pump, but it's not. So that's how fuel pressure regulator is working. Fuel pressure regulator, basically what it does, it regulate the fuel pressure in the fuel rail. And this is the last one. This is called air vent. What it does, when the fuel is filled to this tank, there's some air inside. So this air need to remove, which means air need to bleed. So that is the purpose of this connection here. Remove the vapor inside the VST to fill the fuel to the VST. So this one, if you trace this one is connected to the carbon canister. What carbon canister does, it's filter the fuel vapor and air. It's not 100% filtering, but the carbon canister, they filter the fuel vapor, then there's still excess fuel, it will return to the VST, and after the carbon canister there's a small hose connected to the air intake near the intake filter. Now you understand these four connection. What is the purpose of these four connection? Fuel intake, fuel high pressure supply to the fuel rail, pressure regulator connection connected to the air intake manifold near behind the air cooler. This is air vent connected to the carbon canister. Okay, that is the whole explanation of this each part, what it does. So the Mercury VST is everything fuel pressure and fuel supply. System is controlled with electronically with ECM. Now I will tell you how this one is working. When you on the key without starting, you will hear few seconds these two pump is working. What it does, it's lift the fuel from the tank to the VST, then meantime it's pumping the fuel to the fuel rail. So when you run the engine, what happen, this lift pump is working. If this floater switch is not reached to the upper level, so the ECM give the command to this lift pump. it suck the fuel from the boat fuel tank and supply to the VST. So until this floater switch is reached up to here, this fuel, this lift pump is working. So it's controlled with the ECM, because once this floater switch is reached to here, it will give the command to the ECM, stop the fuel lift pump, because fuel, this tank already full. When engine running, this high pressure pump is continuously working to give the pressure supply, to give the pressurized fuel to the fuel rate. So that's how this Mercury VST is working. So I hope you get an idea, and I hope 90% of almost everything is you understand if you see this video, and you can leave the comments below. And thank you for watching. Please subscribe my video. Thank you for watching. Have a nice day.